Okay, class, today we're in lesson 12.2. Lesson 12.2, Converse of the Pythagorean Theorem. Converse of the Pythagorean Theorem. Section 12.2. Okay, let's get this in our notes. Section 12.2, Converse of the Pythagorean Theorem.
All right, now let me show you a really cool thing about the Pythagorean theorem. So, okay, the Pythagorean theorem, here it is. We have a right triangle. Then we know that if we take the lengths of the sides and then also the length of the hypotenuse, if it's a right triangle, then we know that the sum of the squares of the lengths of the legs will always equal the square of the hypotenuse. Or put it this way, a squared plus b squared will always equal c squared. Here's the really cool thing. The converse of this statement is true, which means that if we have a triangle, any triangle at all, and we look at its lengths of the sides, a, b, and c, and if we can actually get this relationship, a squared plus b squared equals c squared to hold, then the triangle had to have been a right triangle to begin with. The only triangles that satisfy this amazing equation are precisely the right triangles. Why is that cool? It's cool because we can easily tell if, in fact, we have a right triangle or not. For example, suppose I tell you I have a triangle, and the lengths of the sides of the triangle are 15, 20, and 25. Question, is it a right triangle? Answer, I can figure it out by seeing if, in fact, these numbers conform with or satisfy the equation that's associated with the Pythagorean theorem. Now, how do we know where the c is, right? You know, what's c? What's c? Well, c is always the largest number. So this has got to take the role of c. So we can think of this as a, and this is b, and this is c, or you can think of this as b, a, this always is c. That's the important thing. Let's try it. Let's consider 15 squared plus 20 squared. And the question is, does it equal, question mark, question mark, question mark, does it equal 25 squared? Well, let's see. 15 squared is 125. 20 squared is actually 400. And so that actually equals 525. Oh, wait, hold on a second. Wait a second. Hold on. Everyone calm down. If you square 15, you get 225. Why'd you let me make that typo? That silly little typo. There we go. Now when I add these things, I get 625. How does that compare to 25 squared? Well, in fact, 25 squared is exactly 625. So in fact, we see that this equation holds with these numbers. It checks, yes. And so in fact, 15, 20, and 25 are in fact the sides of a right triangle. So in fact, this triangle that has side lengths 15, 20, and 25 is exactly a right triangle. Isn't that cool? I love this stuff. I love it. Let's try one more. Here are three sides of a triangle, 10, 12, 15. In fact, do we have a right triangle? Easy to tell. The largest one's got to be the C. So I've got 10 squared plus 12 squared. Does it equal, question mark, question mark, question mark, question mark, question mark, 15 squared? Well, 10 squared is 100. 12 squared is 144. And does that equal, that's the question, 15 squared, which we know is 225. Well, if we add these two things up, we see 244. It does not equal 225. And so what I see here is that the triangle that has side lengths 10, 12, and 15, in fact, is not a right triangle because it fails to satisfy the Pythagorean theorem. The Pythagorean theorem is an amazing theorem, as we've seen. Not only is it always true for every right triangle, but anytime you have a triangle that actually satisfies the equation associated with the Pythagorean theorem, that triangle had to have been right. The only triangles that work with Pythagoras are right triangles. You're never wrong. I'll see you soon.
Okay, let's continue with working with the converse of the Pythagorean theorem. All right, now we're in example 1 here, and we're going to do the same thing that we just saw in the video, different question. Tell whether each triangle with the given side lengths is a right triangle. A, 9 inches, 40 inches, and 41 inches. 3 sides to a triangle. Let A equal 9, let B equal 40, and let C equal 41. Remember now, the A and B parts, it doesn't matter. The C, the hypotenuse, has to be in the correct position. Don't forget the hypotenuse is across from the right triangle, and it's across from the right angle, and it is always our longest side. So we write our equation down, A squared plus B squared equals C squared. All right, now, the first value we're going to put in is the C value. That's the hypotenuse. That's always the biggest side. And what's the biggest side? 41. So in place of C squared, I'm going to put down 41 squared. Now the A and B, doesn't matter where I put them. So 9 squared plus 40 squared. Now remember, do not add 9 plus 40. Don't do that. First you must square. 9 squared is 81. 40 squared is 1600. And 41 squared is 1681. We add 81 plus 1600, and that gives us 1681, and that is equal to 41 squared, which was 1681. Now, since both sides are equal, that means the triangle is a right triangle by the converse of the Pythagorean theorem. Okay, now let's complete example B. 8 meters, 10 meters, 12 meters. Let A equals 8, let B equals 10, and let C equals 12. We write our formula down. A squared plus B squared equals C squared. The A value was 8, the B value was 10, the C value was 12. Don't forget, 12, that has to be in the right position. That's the biggest number. That's your hypotenuse. All right, 8 squared is 64, 10 squared is 100, 12 squared is 144. 64 plus 100 is 164. So 164 does not equal 144. Since 8 squared plus 10 squared does not equal 12 squared, the triangle is not a right triangle by the converse of the Pythagorean theorem. Okay, let's head to example 2. Using the converse of the Pythagorean theorem, you can use the converse of the Pythagorean theorem to solve real-world problems. Example 2. Katya is buying edging for a triangular flower garden she plans to build in her backyard. If the length of the 3 pieces of edging that she purchased is 13 feet, 10 feet, and 7 feet, will the flower garden be in the shape of a right triangle? Use the converse of the Pythagorean theorem. Remember to use the longest side length as being C. Remember to use the longest length for C. Let A equal 7, B is equal to 10, and C is equal to 13. We write our formula down. A squared plus B squared equals C squared. A value is 7, B value is 10, and the C value is 13. 7 squared, 49. 10 squared, 100. 13 squared, 169. 49 plus 100 is 149. So 149 does not equal 169. Since 7 squared plus 10 squared does not equal 13 squared, the garden will not be in the shape of a right triangle. Remember now, it might be in the shape of a triangle, but not a right triangle. Okay, that completes our examples for today. So let's get started on the lesson.